Hi, it's great to see you again. I'm happy to remain your mentor during this exciting stage of your career as senior engineer. Your new mission to the International Space Station will require you to know how to model complex systems. So where to start? One of the main features of a complex system is its complex behavior. This includes, among other things, conditional behavior and decision nodes. To explain these terms, we will go through a system you are very familiar with by now, a system for creating OPM models in OpCloud. We will model the system as it would integrate in most technology-based companies. The system engineers construct the OPM system model, and when it is ready, they submit it to the product development team. Later in the course, we will see a more comprehensive model that elaborates on this simple picture. Since the main process is synchronous, we will perform in-zooming. SD1 of this model includes 4 sub-processes occurring in the following order: SD constructing, SD1 constructing, above one detail level OPD set constructing, and OPM system model reviewing. As you can see, each one of the first 3 sub-processes creates its own OPD or OPDs, which are all part of the same OPM system model. During the last sub-process, the model is approved for submission to the product development team. The benefit of the system, improving the convenience of constructing an OPM model, is now delivered. Now let us turn to decision nodes and condition links. Decision nodes are informatical objects which represent decisions, usually made by system users or by the system themselves. The existence of a decision node means that the system can take 2 or more different routes at certain stages of their life cycle. In the case of this model, the first major decision a user must make concerns the detailing of the main function and refinement of the main process. Should it be refined, or is the SD on its own enough to describe the system to the level of detail required? Notice we phrase the name of the decision node as a question. While this is not mandatory in OPM, it is a good way to make clear exactly what the decision is. So what happens with either decision? If the system engineers group decides no, then SD is refined and SD1 is created. If they decide yes, then the process of constructing is complete. We call a decision node with 2 states, such as yes and no, a Boolean object. We use condition links to model the 2 different routes in which the system execution can proceed. Condition links are procedural links. They connect objects to processes. Right now, we will use instrument condition links. SD1 constructing occurs if SD main function sufficiently detailed is at state no. Otherwise, SD1 constructing is skipped. OPM system model reviewing occurs if SD main function sufficiently detailed is at state yes. Otherwise, OPM system model reviewing is skipped. The other major decision that the systems engineers group must make is whether to refine SD1. In OPM, you can keep refining functions further and further, creating as many levels of detail as you deem required until you are happy with the level of detail and the guidance it provides to developers and implementers of the system downstream. Here, the systems engineers can choose to either refine SD1 further into more detailed levels of the model, or approve the model for submission to the disciplinary detailed design teams. A condition means that the process cannot occur without the condition being fulfilled. If the condition is not fulfilled, the process is skipped, and the next process in the timeline is performed. We used a condition link to specify that if we choose to submit our model after SD is complete, then we skip all the other processes concerning SD1 and beyond. Note that this is not the case with an instrument link, which is not a condition. A process to which an instrument link is connected cannot be skipped. If the required object does not exist or the object is not in the required state, the system execution will come to a halt when arriving at that process. Only when the instrument becomes existent or it transitions to the required state can the system execution resume. Oh wait, something is still not right with the model. The last sub-process of approving the submission of the model should not depend on both conditions being fulfilled, that SD is sufficiently detailed and that SD1 is sufficiently detailed. It should be either one or the other, but never both. We will learn how to express this in the next time we meet. That's it. Oh look, remember Hopcat? Here he comes again to help us with the definitions.
Boolean object. An informatical object with two opposite states, each leading to a different course of action. Instrument condition link. A link connecting an object or a state to a process, indicating that the object or state is a condition for the occurrence of the connected process. If the object from which the link originates does not exist, or the object is not in the state from which the link originates, then the connected process is skipped.